how are you? The normal distribution is quite familiar probability distribution that every student of statistics have encountered with. It's the most important distribution in statistics, often used in confidence intervals for population parameter estimation and also in hypothesis testing. And many times when you are using parametric tests, you need the assumption of normal distribution to be respected in your observations. Today we are going to understand three empirical rules widely used when applying normal distribution. These three numbers you see on the slide, 68%, 95%, 99%. What are they? What do they represent? And what these probabilities mean? So let's get started. As an example, we take the mass of 30 students in a class. We assume the mass to be normally distributed. The mean is 60 kilogram. The standard deviation is 5 kilogram. We need to show that 95% of students' mass to lie within 2 standard deviation of the mean. Graphically, this is what we are asking. We need to find the probability between these two intervals. 2 times sigma is 2 standard deviation added to the mean. The mean is the central. So on the right we have 2 standard deviation of the mean, and on the right we have also 2 standard deviation of the mean, plus minus. We subtract on either side of the mean 2 standard deviation of the 2 standard deviation we add on the right, 2 standard deviation we subtract from the right. To answer this question, this is the given data. The mean is 60 and the sigma is 5. 2 standard deviation of the mean is mu, which is the mean minus 2 sigma, 2 standard deviation. If we substitute mu 60 and sigma 5, we get this interval 50 and 70. Graphically, this is what we are asking for. We are asking for to find the probability corresponding to this interval 50 up to 70. 50 is 2 standard deviation from the mean, and 70 is 2 standard deviation from the mean. So to find this probability, mean is the area under this normal distribution curve over this interval. It's the probability that the random variable x along the x-axis is between 50 and 70 will correspond to this probability that we will find soon. To use the normal distribution table, z table, we are going to convert this 50 and 70 into z, or the z scores. And the way we are doing is that we are going to use this formula. The z score is x can be 50 or 70 minus the mean, which was 60, divided by the standard deviation, which was 5. So let's convert this 50 into standard normal distribution. We are going to get minus 2, and for the other value we are going to get 2. So instead of finding probability that a given value of x is between 50 and 70, we are going to find probability that the normal distribution, the standard distribution, or the z, is between minus 2 and 2. So here what we did is that we converted this normal distribution, which is generic, into the standard normal distribution. So probability of z minus 2 to 2 means that the left tail probability of z less than or equal to 2 minus probability of z less than or equal to minus 2. We can now use the normal distribution table. We get these two values. Probability of z less than 2 is 0.9778. Probability of z less than minus 2 is 0.022. If we substitute, we get 0.95. So this result shows that because we wanted to find the probability corresponding to two standard deviations on either side of the mean, that probability is going to be 95%. So this is called 95% confidence level or 95% empirical rule. That's where it came from. 95% it came from two standard deviations from on either side of the mean when you have normal distribution observations. We have other two empirical rules, 68 and 99%, as you can see in here. So I hope now you find it a little bit clear. If you need more understanding on this concept, plus other statistical tests like parametric tests of one sample, two sample, three sample, also non-parametric tests, and doing those tests in SPSS, why don't you go to Amazon and find this book? I hope it will help you. Thank you so much.